course it's frozen. Now, we are going to do both journals today because the first one is very, very, very quick. And the other one is stuff that isn't necessarily new to you guys. All right. So, with polynomials, it's just another fancy name for something that you already know. All right. So before we get into that, we'll first write our I can statement. So just write it either above it if you have space or below it or just off to the side, wherever. So 7.1a's I can statement is I can write a polynomial in standard form and classify it by its number of terms and degree. All right. So there's a lot of new vocabulary that you're going to be learning. So what a polynomial is, what standard form is, which you may have heard about before in certain ways, terms and degree. All right. They mean different things in this setting. So you may think that when you think degree, you may think temperature. Not in this case. All right. So first off, we need to know what a polynomial actually is. All right. So a polynomial is just an expression. So remember, an expression means you do not have an equal sign or a greater than, less than, or equal to sign, with one or more terms separated by addition or a plus and subtraction or a minus. So remember, a term can be anything being multiplied or divided. So a term could be 8m, a term could be x squared, a term could be 2. All right. And the way you know where the terms start and end is that they're separated by pluses and minuses. All right. Now, there are some conditions to what can qualify a polynomial and what cannot be a polynomial. So, polynomials can have any real numbers. So, those numbers can be whole, they can be positive, they can be negative, they can be fractions, they can even be radicals, so like square root 3, square root 2, square root 50. All right, those are called irrational numbers, which you'll learn about later. As long as it falls under the real number umbrella, it can be used in polynomials. It also can have variables, and it doesn't have to be the same variable. It can have an x, it can have a y, a, b, c, d, whatever. You can have multiple variables in a polynomial, so you can have x and y at the same time. The only condition is that those variables can only be in the numerator. So if you have fractions, it cannot be in the denominator. That variable cannot be in the denominator. And then finally, you can have exponents. But they must be positive whole numbers only. So no negative exponents, no fractions. Which you're like, fraction and an exponent, you'll learn about that in math too. Now, some examples of polynomials. Just to name a few, you can have x squared plus 4, the square root of 3 x to the fourth plus y squared, just 8m, and negative 5x squared plus 3x plus 2. Any of those could be considered polynomials because it contains all real numbers. It has variables, but they're only in the numerators. And it has exponents, but they're all positive and they're all whole numbers, so no fractions. All right. Now, on the flip side, I already mentioned a couple of these, but polynomials cannot have negative fractional exponents. So they can't be negative. The exponents can't be negative. They can't be fractions. You can't have division by a variable. So there can't be any letters in the denominator. And you can't have any variables under the radical symbol. So remember, the radical symbol is a symbol like that. That's the radical. If your variables fall under that bar, it is not a polynomial. So, some examples of non-polynomials. We have 8x to the negative 2, the square root of 3x to the fourth plus 2, 1 over x plus 2x squared, 8x squared plus 3x to the 1/3. So, the first one's not a polynomial because of this negative exponent. The second one is not a polynomial because we have a variable falling underneath the radical. The third one is not a polynomial because there is a variable in a variable in the denominator. And then the last one isn't a polynomial because it has a fraction in the exponent. So if you see any of those things, it's already considered not a polynomial. Now, you may wonder, what's the difference between this and what I had up here, this? All right. The difference is, for this radical, only the 3 falls underneath that bar. The x to the fourth's on the outside. Whereas for this radical, both are underneath that radical bar. All right, so that's the difference. All right, so be careful about that, especially when you're looking at the radicals. All right. Now, not only are you going to be classifying whether it's a polynomial or not, you also need to classify it based off of its subtype. So, polynomial is a very broad term, but there are 3 different subtypes of polynomials, and the way we know is based off of the number of terms. So, the 3 main types of polynomials that you'll see in this class are monomials, binomials, and trinomials. All right, and then of course just a polynomial. So if it doesn't fall under one of these 3 categories, if your polynomial doesn't fall under one of those 3 categories, it's automatically a polynomial. All right. Now, monomial. So all 3 of these subtypes are based off of the number of terms. So when you hear monomial, how many terms do you think it's going to have? 1, because it says mono. All right. That means 1. So 1 term. So that means you shouldn't have a plus or minus anywhere. So an example would be 8x squared. That's a monomial. There's no addition, there's no subtraction. It's just some multiplication. What about binomial? How many terms do you think it has? 2, because it says bi. All right. So that means it has two terms. So an example could be x plus 4. So remember, the two terms are the two values separated by that plus. So there's one term here, two terms here. What about trinomial? It's 3 because it says tri. An example of a trinomial would be x squared plus 2x plus 4. Because again, here's one term, then a plus, second term, plus, and then a third term. So remember, terms are separated by pluses and minuses. All right. Now, if it has more than 3 terms, it is considered just a polynomial. There's no fancy name for it. So if it has more than 3 terms, so 4 terms, 5 terms, 6 terms, so on and so forth, it will be just considered a polynomial. So an example of that would be x cubed plus 2x squared minus 4x plus 5. So here's 1, 2, 3, 4 terms. So this particular polynomial has 4 terms. And you will have to be able to identify the number of terms in a polynomial. So if I asked you to name a polynomial, the first thing that you use when naming a polynomial or classifying a polynomial is its subtype. Is it a monomial, binomial, trinomial, or just a straight up polynomial? All right. Any questions on how to identify the subtypes? Now, there's also another way that we identify a polynomial, and that is through its degree. All right. Now, again, when you think of the word degree, what do you think of? So, what typically pops in your mind when you hear the word degree? Temperature, 60 degrees, 70 degrees. This is actually not like temperature or not like an angle measure. It's completely different. So, all degree means in terms of polynomial is that it's the value or the number. So, by value, I mean number of the highest exponent. So it's the highest exponent in a polynomial. Now, occasionally, you won't see this often in this class, but occasionally you will have more, if you have more than one variable in a term. So by that, like for example, if you had xy squared, that's one term. So more than one variable in that term. All you do is just add the exponents of both variables to determine the degree. So if I added these two exponents, that means my degree would be 3. So if I ask you to tell me the degree of this monomial, it'd be 3 because you would add those two exponents together. Now, something else I may ask you is what is the leading coefficient? So when you hear the word coefficient, what do I mean by that? What does the word coefficient mean in math? We talked about this, maybe not necessarily with me, but we talked about this last semester. It's the number connected or in front of the variable. So it's the value of the number in front of the term with the highest exponent. So whichever term has the highest exponent, the leading coefficient is that number in front of it. So let's look at an example. So this polynomial at the bottom, 2x to the fourth plus 5x squared minus 4. it's pointing, the arrows are pointing to two different things. So the first thing is here. The second is here. What would the yellow highlight be called, that 2? What do you think that is? The leading coefficient. So if I asked you to tell me the leading coefficient, it would be 2. What about the blue highlights? Is that 4? That's the degree, because that's the highest exponent. So if I asked you to state the degree of that polynomial, you would state that it has a degree of 4, or a 4th degree polynomial, however you want to state it. All right. And then the last part, when it comes to polynomials and its classification, this especially comes in handy when you're trying to figure out the degree, is standard form. Now, we've talked about standard form in terms of a linear sense. All right. Kind of similar, but not quite. So basically, when we talk about standard form with polynomials, we want the terms in order from highest degree to the lowest degree. So terms are in order from highest to lowest. So basically, you take the exponents and you put them in order from highest to lowest. So an example of this would be x cubed plus 5x squared plus 2. So if you look, it goes 3, 2. Now, if we have a constant, what's technically the exponent? Not 1. So there's an invisible x here. And what exponent is connected to that x to make it just 2? 0. So this has an invisible x to the 0 power. So if you see a constant, it has an invisible x to the 0 power. Now, if you just had flat out x, that would be the exponent of 1. Now, a non-example would be x squared plus 5x cubed plus 2x. Why is that not an example of standard form? What's the issue with that example? Look at the exponents. Are they in order from highest to lowest? No. Because if they were, this 3 would come before the 2. Also, don't forget, if you just see an x, the exponent is 1. All right? So standard form is from highest to lowest exponent. So you can make a note that by degree, we mean exponent. All right? So now let's do some examples. So let's look at example 1. So we're given this polynomial first. The first thing they ask us to do is to put it in standard form. So out of those 3 terms, here, here, and here, what would go first? 6x to the 7th, because that's our highest exponent. What will go next? 2x cubed, so plus 2x cubed. And then the negative 5x is our last term. Now, something to note. If you're rearranging in standard form, keep the sign with the term. So if there's a negative in front of that term and you're rearranging, make sure that negative stays with it. If there's a positive in front of that term, make sure the positive stays with it, especially when you're rearranging. All right. Now, how many terms do I have here? We have 3 terms. So 1, 2, 3. So if we have 3 terms, what type of polynomial is this? It's a trinomial. What's its degree? 7. That's our highest exponent, so our degree is 7. And so what's our leading coefficient? 6. Because it's right here. All right. Let's try another one. So number 2, let's put it in standard form first. So what comes first? 3a to the 5th. And then the minus 8 comes after. How many terms do we got? 2. Guys, heads up, please. So if we have 2 terms, what type of polynomial? It's a binomial. 2 terms, binomial. What's our degree? It's 5. That's our highest exponent. So if our degree is 5, what's the leading coefficient? 3. Not too hard, right? Now, the last one's a little tricky because we actually have multiple variables. So the first thing we're going to do is figure out the degree of all the terms. So remember, when you have multiple variables in one term, you add the exponents. So for the 3xy, the x and the y both have an exponent of 1. So if I add them together, what's the degree? 2. 6x is just the 1, so it's by itself. Now, the 4x squared to the y, all right? Remember, the y has an unspoken 1. If I add those two exponents together, what would that degree be? 3. All right? So, and then the -2 is just the exponent of 0. So, now we know enough information to put in standard form. So, based it off of which term has the highest degree. Which term is that? What goes first? The 4x squared y, because it has a 3 if you add the two exponents together. What comes next? The 3xy, because it has a degree of 2. What's next? Minus 6x, because it has a degree of 1. And then minus 2, because that has a degree of 0. Because remember, there's an unspoken x to the 0 there. How many terms do I got? 4. So what type of polynomial is it if we have 4 terms? It's just a polynomial. What's the degree? 3. When we added up our exponents, it was the highest was 3. So what's the leading coefficient? 4. Good. Any questions on classifying polynomials and their key features? All right. The last part that we're going to do today is the adding and subtracting of the polynomial. So look at that little booklet that I had you guys make. So there's another I can statement at the top. So just write it up top if you have room. So 7.1b is I can add dash subtract polynomials by distributing and combining like terms. So, keyword there, combining like terms. Don't we already know how to combine like terms? Yeah, you guys should know how to combine like terms. So, it's really nothing new. You're just kind of doing it in a different context. All right. So, open up your booklet to the very first page. So, it should look like, it should say find the sum at the top and then adding at the bottom. All right. Let's just look at the first example. So example 1. So when we're combining like terms, because when we're trying to find the sum, that means that we are going to combine like terms. All right. So when you're finding the sum, you are combining. If I can spell combining right. No, I did. You're combining like terms, always. Whenever you're adding or subtracting, you're always combining like terms. Now, make a note of this because you're not used to combining like terms past a linear type situation. So, by combining like terms, it has to have a like term means it has the same variable and the same exponent. And all you do is add the numbers. So then all you do is add the numbers in front of the variable. You do not change the exponent in the variable. You do not change the variable itself. All you do is adding numbers. All right. So my suggestion to you is that when you start combining like terms, figure out what your like terms are first. And either maybe highlight them in different colors or draw different shapes around them, just so you know, okay, these are the ones I'm combining. So, with like terms, all right, number 1, can someone name me one set of like terms here? So, what are some like terms in example 1? Negative 2x and x. All right, so one set of like terms that I have is negative 2x plus x. All right, what's the other set? Negative 9 and 4. So I then would have plus negative 9 plus 4. Now, whenever you're combining like terms with a polynomial, I want your answer in standard form. So from highest to lowest exponent. So I always want your answer in standard form. All right. Now, remember. So, if we're adding or subtracting the x's, remember, you're only adding and subtracting the numbers in front of them. So remember, there's an unspoken 1 here. So what's negative 2 plus 1? So guys, negative 2 plus 1, what is that? Negative 1. So this would be negative 1 and then slap an x on the end. All right. What's negative 9 plus 4? I'll give you a hint. The same thing as 9 minus 4. Negative 5. So this would be our answer, and it is in standard form. And another way you could state this is negative x minus 5. Now, just for funsies, what type of polynomial is that? It's a binomial. What degree would it have? 1. So if it has a degree of 1, what type of function is it? What does that look like to you? What type of function does that look like to you? It looks linear. All right. So if you want to get really official with the names, you call this a linear binomial. Because all linear means is that it has a degree of 1. All right, let's try another example. So I know you'll be able to do example 2, so let's skip down to example 3. All right, example 3 has some extra values in there. We got some exponents in there now. So remember, like terms, same variable, same exponent. So can someone name me one set of like terms here? The x's would work. What's the other set? The x squareds. And then that plus 1 is just by itself. So don't forget to include that plus 1, even if it is by itself. So if I wanted to write this, adding them in standard form, what would come first? What variable? Would it be the x squared, the x, or the constant? If I wanted it to be in standard form, what comes first? It'll be the x squareds. So I would do 3x squared plus 6x squared plus, what will come next? So we got the x squareds. What will come next in standard form? Right, the negative 2x plus 3x. And then we have the plus 1. Don't forget to bring down that plus 1. So what's 3x squared plus 6x squared? Remember, you're just adding the coefficients. 9x squared. All right. So this would be 9x squared. What's negative 2x plus 3x? 1x. So plus 1x, or I'm just going to put x. And then since the plus 1's by itself, we just bring it down. So this would be my simplified answer. Now, just for funsies, what type of polynomial is this? It's a trinomial. What's its degree? 2. Now, you may not know this, but if it has a degree of 2, this is called a quadratic, which you guys will be hearing a lot of in the next unit. So this is a quadratic trinomial. And all quadratic means is that it has a degree of 2. That's all quadratic means. It has a degree of 2. All right. Any questions on the simple adding like terms? All right, let's look at one where we kind of do a little bit more work. All right. Let's look at example 5. So, what's something that you notice that's different than the couple of examples that we've already done? What's different? There's numbers outside the parentheses. So if there's numbers outside the parentheses, what do you think we're going to have to do first? Distribute. So if you have numbers outside of those parentheses and it looks like it's multiplication, you got to distribute first before you combine the like terms. All right. So if I distribute, that means I would have 20x cubed minus 5 times negative 2 is 10, x squared, and then 5 times 1 is 5, so plus 5, plus, so again, when you're distributing, just multiply the number, slap whatever variable it is on the end. So 3 times 7x squared is 21x squared. 3 times negative 5 is negative 15x. 3 times negative 4 is negative 12. Now, once I distribute, now I can go into combining like terms. So what is one set of like terms that I have? The x squareds. So the x squareds, So negative 10x squared and 21x squared, those are some like terms. What's another set? There's one more. 5 and negative 12, they're both constants. So if they don't have a variable on the end, they are considered like terms. Now, the 20x cubed and the negative 15x are on their own. All right. So we still got to bring those two down, but we're just not going to change their number at all because we're not combining them with anything. So again, if we're going in standard form, what's the first thing I will do? So which term comes first if it's in standard form? Which one has the highest exponent? The 20x cubed. So we're going to start with 20x cubed plus, what's the next set of values in standard form that will come next? The x squareds. So it'd be negative 10x squared plus 21x squared. What comes next? So in the pecking order, what's the next highest exponent after the cubes and the squareds? So all that we have left is 15x and two constants. It's 15x. Because if you still have a variable that has an exponent of 1, constants have an exponent of 0. All right. So this would be minus 15x and then plus 5 minus 12. And then we just combine like terms. So I bring down the 20x cubed. Negative 10 plus 21 is positive 11x squared. I bring down the negative 15x. And then 5 minus 12, that is negative 7. So this would be my combined answer. Now, what type of polynomial is this? It's just a polynomial. What's its degree? 3. So the fancy name for a degree of 3 polynomial is what we call a cubic polynomial. And again, all cubic means is that it has a degree of 3. All right, so if you want to get fancy, you can name it that way, but otherwise, just say degree of 3. All right, any questions on adding? Guys, heads up, come on. If you don't want to put your heads up, you'll be standing up. Come on. All right, so that's adding polynomials. So now turn to the next page. Subtracting polynomials. Very, very similar to adding polynomials. We're still combining like terms. However, there is one extra step. What do you think that extra step is? So let me ask you this. We got this negative right here. So we got this negative right here. All right. And it's outside a set of parentheses. What do you think we're going to do? Doesn't this part right here look like a distribution problem? What would we distribute? The negative 1. So whenever you're subtracting two polynomials, before you combine like terms, you always distribute the negative. All right, that's always the first step. So we're going to distribute the negative to these two terms. And remember, that's the same thing as multiplying by negative 1. So I still got 7x plus 10 But now I have minus 3x, because positive times negative is negative, and then plus 8, because a negative times a negative is a positive. Now I can combine like terms. So what's one set of like terms that I got? So the 7x and the 3x, and then the 10 and the 8. So in standard form, we would have 7x minus 3x plus 10 plus 8. So a subtraction problem is just an addition problem in disguise. You just have to do one more step. So what do you think my final answer would be if you combine like terms? 4x, 7x minus 3x is 4x, plus 18. 10 plus 8 is 18. All right. Any questions on example 1? All right, let's look all the way at example 5. So, example 5. What's going on here? What do we have to do first before we can do any combining? We need to distribute the numbers to all the parentheses. And you can also distribute the negative at the same time. So we'll distribute, boom, 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 that negative 7 to the first set of parentheses. Then, Ralph, where are you going? Yes, but remember to ask me next time. Then you can go ahead and distribute the negative 5 to the second set. That'll take care of the distributing the negative. So, what's negative 7 times 2x to the fourth? So, guys, what's negative 7 times 2? Negative 14. And then we just slap on an x to the fourth on the end. So, what's negative 7 times 3x cubed? Right, negative 21x cubed. So, guys, whenever you're distributing a number to parts of a polynomial, just multiply the two coefficients together and slap on whatever variable is on the end. All right. What about negative 7 times x? What's the unspoken? Right, negative 7x. There's an unspoken 1 here. And then negative 7 times negative 1 is just positive 7. What's negative 5 times negative 3x cubed? Positive 15x cubed. What's negative 5 plus 4x squared? Times 4x squared. Negative 20x squared. Negative 5 times 8x is negative 40x. Negative 5 times negative 6 is positive 30. So, a lot going on there. A lot of terms. But now we're in our combining phase. So, what's one set of like terms? So, someone just name me one set of like terms. So, remember, same variable, same exponent. Right, my x cubed. So, negative 21x cubed and 15x cubed. What's another set? Negative 7x, negative 40x. What's another set? 7 and 30. Do I have any more sets of like terms? Yes. So that means the negative 14x to the fourth is on its own. The negative 20x squared is on its own. But you still got to bring it down. So it's still important to know that, oh, it's still there. So if I put this in standard form, I would have the x to the fourth first because that's the highest exponent. So negative 14x to the fourth plus negative 21x cubed plus 15x cubed plus, or actually just minus 20x squared because it's by itself, plus negative 7x minus 40x plus 7 plus 30. So guys, sometimes you can just skip that step and go right into adding, but if you need to see it where all the addition is, write it like this. Just take the extra minute and write it like that. So the negative 14 x to the fourth comes down. What's negative 21 plus 15? So think about it this way. What's 21 minus 15? It'd be 6. So this would be a negative 6x cubed because the 21, the bigger number, is negative. Bring down the negative 20x squared. Negative 7x minus 40x, that's like adding two negatives. So we have negative 47x. And then 7 plus 30 is 37. So this big boy is our answer. Any questions on this one? Okay, one more subtraction just to hit home. So look at, let's just do number 4. So with number 4, what's the first thing I got to do before I can add like terms? Distribute that negative. So we got to distribute that negative to the second set of parentheses. So if I do that, I get 4x cubed plus x squared minus 9x minus 8. 7 times a negative is negative 7x cubed. 2 times a negative is negative 2x. 6 times a negative is negative 6. So another way to think about distribute the negative, just flip the signs of the terms that are in the second parentheses, and you have now distribute the negative. Now, I'm doing this quickly. My like terms are my x cubes and my x's and my constants. The x squared is on its own. So if I'm writing in standard form, what variable and exponent comes first? The x cubes. So this would be 4x cubed minus 7x cubed plus the x squared plus negative 9x minus 2x plus negative 8 minus 6. All right. So to combine those like terms, 4 minus 7 is negative 3x cubed. Bring down that x squared. Negative 9x, so negative 9 plus negative 2 is negative 11x. And then negative 8, negative 6 is negative 14. So again, I'm flying through this because combining like terms shouldn't be something that you're unfamiliar with. Guys, again, heads up where you're standing up. Any questions on adding and subtracting polynomials? All right, the very last thing that we're going to do is some geometric applications of combining like terms. And the geometric application here is through perimeter. So when you hear the word perimeter, what does that mean? Add all the sides. So guess what we're going to do for number 1? Add all the sides. So I'm going to have negative x squared plus 11x plus 8 plus 4x squared minus x plus 10 plus 2x squared plus 5x minus 3. All you got to do, even though there's variables in there, we're not solving for anything. They just want us to simplify the expression. And to do that, we would just add up all the sides. So my like terms here would be my x squareds, my x's, and my constants. All right. So a little more sustenance here. All right. So if we're writing in standard form, what highlighted color comes first, the yellow, green, or blue? What color? Which one has the highest exponent? The yellow, or our x squareds. So I'm going to do negative x squared plus 4x squared plus 2x squared plus what highlighted color comes next, green or blue? If we want standard form, which has the next highest exponent. So the x's are the constants. Which one has the highest? The x's. So this would be 11x minus x plus 5x. And then our constants. So 8 plus 10 minus 3. And then we're just combining the like terms. So remember, there's an unspoken 1 here. So negative 1 plus 4 is 3, plus 2 is 5x squared. So guys, if you need help with that, put those numbers in a calculator. That's totally fine. Remember, unspoken 1 here. 11 minus 1 is 10, plus 5 is 15. 8 plus 10 is 18, minus 3 is 15. So this would be equal to my perimeter. So even though it looks complicated, it's actually not. Now, look at number 2. So number 2, they only gave us 2 sides. However, we technically already know the 2 missing sides. How do we know them? They're the same. How do you know that they're the same? Well, it is a quadrilateral, looks like a parallelogram, but the reason that we know they're exactly the same is these tick marks right here. If you see tick marks like that on the sides of a shape, and they have like the same number of tick marks, those tick marks stand for congruent sides. So that means that these 2 side lengths are congruent or equal, if you want to put it that way. And these 2 side lengths are congruent. So tick marks mean congruency. So if you see a tick mark, that means congruent sides. And then you just match the number of tick marks. So 1 tick mark goes to 1 tick mark, 2 tick marks go to 2 tick marks. So what would be the missing side of the green tick mark? What's that length? So the green tick mark, the one I circled green, what's that length? Right, 2x squared minus 6x, because that is the corresponding one. What about on the other tick mark? What's that length? Negative 5x squared plus 10x minus 4. And then from there, we would just do exactly what we did in the last one. So I'm not going to work that one out because it's the exact same as the last process. But I just wanted to show you that when you see those tick marks, that's how you figure out those sides. Does everyone get that? So again, tick marks right here being congruent sides. And then you match the tick marks to know which sides are the congruent ones. So if it has both has one tick mark, these sides are congruent. 2 tick marks, these 2 sides are congruent. All right. Last part, and then we're done. So number 3, the perimeter of the quadrilateral shown below is 29x plus 5. And it wants to know what is the length of the missing side. So this missing side here. Now, ignore the variables for a second. If we were asked to do this with numbers, like just straight up numbers, what would be the strategy that you would do? So like hypothetically, let's say that, and don't write this down, but hypothetically, the perimeter was 15 and this was 2, 3, and 7. All right, those were the lengths of those sides. How would you use that knowledge to find the missing side? What would you do? Add up all the sides that they give you, subtract it from the perimeter. So that's exactly what we're going to do. We're going to add all sides given, then subtract from the perimeter. All right. So I'm going to add up all 3 of my sides first. So I have 5x plus 3 plus 10x plus 7 plus 8x minus 4. So again, those numbers are non-existent, so you don't have to write those, but these you do. So this is the adding up all my sides part. And to do that, we just combine like terms. So my like terms here are what? So your x's first, and then your constants. So that means I have 5x plus 10x plus 8x plus 3 plus 7 minus 4. So if I combine like terms, 5 plus 10 is 15, plus 8 is 23. X. 3 plus 7 is 10, minus 4 is 6, plus 6. So this is the length of the 3 sides. So this is the 3 sides that we're given. Now, I then subtract it from my perimeter. So your perimeter is 29x plus 5 minus, and put this in parentheses because remember we got to distribute that negative, minus 23x plus 6. So if you ever have to set up your own subtraction problem, just make sure the second expression that you're subtracting is in parentheses. So you remember to distribute that negative. Because like I said, we distribute the negative first. So we get 29x plus 5 minus 23x minus 6. All I did was change the signs within the parentheses because I distributed that negative. And then combine the like terms. So the x's and the constants. This would be 29x minus 23x plus 5 minus 6. So if we combine like terms, I would get 6x because that's 29 minus 23. And then 5 minus 6 is 1. So this right here is my missing side. That's my missing side right there. So in other words, this side up here, where the question mark is, would be 6x minus 1. Any questions on any of this? And again, I went through it rather quickly because, again, combining like terms should not be anything new to you. The only difference is that you have a bit more exponents in the terms, but that shouldn't matter anyway. So any questions on any of this? All right. So you only got about 15 minutes left of class. So 2 things. There is a delta math on this. It's pretty quick. Your packet work, which your packet is that other packet that you had to grab, the one with the hole punches in it. That's the packet for this unit, or at least the first half of it. Your packet work would be pages 1 through, I think, 3. So pages 1 through, 3. Pages 1 through 3 is the packet work. All right. And then I'll post your exit ticket.